Good evening, everyone. I'm very glad and honored to have the opportunity to present you a few things about what can be a smart ticketed space. Maybe I will start to say that the large part of the space activity will not be the subject this evening, because I will try to mainly talk about how to go there and not and maybe what can be done in the future, but I will not address all the topics which are the current use of space. The fact that today every of us is using about 50 satellites per day for your classical purposes. First of all, my speech will start with the access to space, and then after that we will go forward, leaving Earth and going to other planets and maybe other futures. So a few words first, talking about access to space. As we are talking from Paris, Europe, and connected with Germany and Italy, we cannot avoid to have a picture of what is foreseen to be Ariane 6 in few months now for the first flight. So this is the heavy access for Europeans to space. There are other launchers, in particular mainly, let's say, Italian rocket, which is the bigger rocket. But for a lot of purposes, this Ariane story was a European story involving 14 countries from the very beginning, in order to find a way to be together and connect the people and to find a path in order to not let just at this time the Americans and the Russians having access to space. And we have to say that it was invented very at the very beginning of Ariane, so in the year 1980. That using the commercial market is a way to help the benefits of the public use of space. So saying it in another way, Ariane has been used much more for selling private satellites by the creation of Arianespace at the very beginning, in order to let one launch per year, or more or less, which was focused on public services, and all the others were for mainly American customers, in fact, at this time. And it was the idea that few Europeans had to allow to compete with Americans. They said, let us try to find something which is easier and smaller than the space shuttle, which was the competitor at the time, and to make money with it in order to have our autonomy of access to space. So this is exactly the same spirit that what is today the new space, where a large amount of private money is supporting the activities for the community, the public services. And this is the next picture. This one is the one of a Falcon 9 rocket of SpaceX, the company of Elon Musk, which has replayed and even surpassed this idea that was the one of Arianespace at the very beginning, saying that I have to offer a service, not just a launch, to offer a service and offer it at a competitive price in order to fly even every week. It was the target, to fly very often, in order to be able to amortize a reusable launcher, which is a loss of energy. You have to understand that if only the space shuttle was reusable in the United States before, it was because it has to come back with all the crew. So it was not for saving money, it was for saving the people. But Elon Musk has decided at the very beginning that having contracts for much more launches allow to reuse them. He said it's such a pity to draw in the sea, in the water, and the ocean. Hundreds of millions of dollars of very expensive materials. So the idea was to say, I will lose, and it was the case, I will lose half of the performance. So the launcher, the cost of the launcher is twice, but as I can recover it, at the end, after a certain number of flights, at the end, it's even an economic interest. So it is something which has not been decided in Europe on our side, because, as I said, there is not the same volume of activity. And with 6 to 10 launch per year for the whole Europe, counting private and public, it was not enough at this time with the technology which was available at the end of RN5 and RN6 to say that we can save the public money, because it's mainly paid by public money. It was not a way to save the public money. So the way was to say, let us continue on the bargain to launch once a year for the public, and 90% for foreign customers, mainly Americans. But the things are changing, because now the Americans have a cheap way to go to space, and they are not buying like before all these rides on Ariane. And the fact that, and this is the very, very nice pictures of the two boosters, two lateral boosters of the heavy version of the Falcon 9 of Elon Musk, which were coming back together on ground. So with the success of this launcher, because the Falcon 9 has only half of the performance of an Ariane 5. In fact, it was sufficient for a certain amount of missions, but clearly not enough for a lot of American foreseen, let's say, defense application. At least, and also the capability to deliver very low payload on the low orbit for the interest of the National Space Station and other exploratory works. So this idea to put together three core of a rocket and to recover at least two of them, the third one being too fast to survive to the re-entry in atmosphere. So it has been tested twice, but it was always a failure. But it was expected to be a failure, because at this velocity, everything burns down if it is not correctly designed for being able to return. So this is the rest of the story, the second step before the one which we'll see after, of the Elon Musk success, being able to recover not only one but two boosters. Just to have a picture in order to understand a bit what we are talking about. I was talking of Ariane, RN5 or RN6, it's about the same performance. 6 is a bit more, but not too much. But it's not an heavy launcher. It's an heavy launcher, but it's not a super heavy launcher. And what's happened now is that we see some very teeny launchers coming back, like it was at the very beginning of the rocket scientist period. And we have huge super heavy launchers, they're called, launchers which are arriving in all the faring space countries. So Russia, as you see, it was before, and today they don't have anymore the capability to develop them. And I mean, they foresee to do it with the Angara, but we know that it's 20 years that it should fly the next year. So we'll see what happens. Then we have United States, yes, of course, which is playing on let's say with two different legs, if I could say. So the legacy very heavy rockets which are made by Boeing, Lockheed Martin. I mean, let's say what the people would have called today the old space, even they are not old, but the comparison with the new space. So those SLS rockets which are used. Which should be used normally to go to the moon and maybe to Mars, and the competitor, which is SpaceX, arriving now with this Falcon Heavy. You see the two boosters on the side, which came back. But after that, at the top right, this Starship rocket. And maybe some of you had the opportunity to see some picture of this rocket, but it's interesting that you know now the size it has. Just having a look on the Airbus 380, which is in fact the body of the 380 is smaller than the spaceship. So a lot of people just think that it is today Elon Musk is playing with kind of small demonstrators and so on. No, they are demonstrators, because they are not meant to survive. Today he is testing in iterative mode some new functionalities. but every time it just crashes the vehicle which is bigger than the biggest airplane, commercial airplane. Just to let understand that it's not such easy to go to space. Only a fraction of the mass at liftoff reached the orbit, about 2% for the low orbit, and even less if we go further. So it means that 99% of the mass is yes, it's lost or consumed, wasted, consumed for the purpose of propulsion when you are talking of fuels, and lost when it is expandable launchers, and recovered or partially recovered when it's a reusable launcher. But as I said, to carry the same payload, a reusable launcher needs to be about twice bigger, because the efficiency is depends exactly of the trajectory and so on. But it's really painful for the performance to have the launcher back, but very useful for the economy. So this is a picture of this huge, even if you don't feel it huge, of this huge vehicle coming back to Earth with success this time. So 3 failures and the fourth was a success. Landed in the vertical mode using the retro propulsion of the rocket engines to brake just in time to be able to have a zero velocity when arriving on Earth, exactly like the LEM did on the Moon, because on Moon there is no atmosphere, so you cannot use any wings. You have no other solutions than to brake with your engines, and it is what have been chosen by Elon Musk for his launchers. Not because it's easier, because as I said, you see that it's not such easy to do, but because it is fully needed for its purpose, which is to go to Mars. And landing on Mars is not feasible with wings. The atmosphere on Mars is only 1/10 of what it is on Earth. So it means that at ground level on Mars, the atmosphere is as thinny as at 30 kilometers of altitude on Earth. So you know that very few aircraft can fly, and if they fly at very high speed. So it means that if you want to land on Mars, you need to be supersonic. I mean, you need to land down at more than 1,000 kilometers per hour. So it means that you need to find a nice runway. Yes, a nice runway, like very long runway. Nobody was there, so it's not possible. So the only way to land on Mars is like this. And this is why Elon Musk has chosen this way. And as he needed to test it on Earth, it means that also it's an opportunity to use it on Earth. But it's not the safer one. Of course, you are a lot of depending from the ignition of the rocket engines exactly at the correct second, at the 10th of seconds in reality, if you don't want to hit the ground. So the next picture is the same vehicle, which is really a game changer. Because it's a bit like most of us can go to work using a bicycle or a small motorbike or something like this, but most of us are using a large car, which is done for something else. Even if it's empty, okay, we use a large car. So Elon Musk has the same idea, saying that rather than making a lot of small rockets dedicated to a lot of purposes and so on, like the old style, if I can say, because the efficiency was always focused on the performance of the payload reaching orbit. He decided to say, okay, I make something which is really very big. So, but it's not a problem because I recover it. I want to recover it at 100%. I recover everything. And it will allow me to perform all the missions, because I can down the price, not because it is tuned exactly on your purpose, but I down the price because it's able to do everything and I recover it. So it's a business model which is completely different. And it is also the fact that this Starship has been chosen a few weeks ago by NASA to perform landing on the moon, and but also not only the landing, but also giving some room for the astronauts. Exactly, it's a kind of a large Swiss knife. It's the idea is this one. And this picture, which the space shuttle and the Starship also let you understand what I'm talking about. It's really a huge, huge vehicle. So Elon Musk is not the only one, which is trying to change the use of space. I mean, not going to space just as a target, but of course it remains a target for Elon Musk and for Bezos, but it's also a way to make money, provide services. It's a mean. Space in that case for them is not only a target, it's also a mean to make money, to deliver services which allows to make money. And this launcher, it's a very heavy launcher also, which is foreseen to fly soon, probably, in the United States. So Elon Musk will have a competitor. And this is just to recall that on the picture, which was some time before, on the far end left, I did put a teeny micro launcher to let you understand what it is. And this is a micro launcher which has been developed by a friend in New Zealand. And we discussed together, and I said to him, try to avoid any expensive workshop. So try to have nothing that weighs more than 20 or 30 kilograms in order that it can be carried by 1 or 2 people, avoiding to have a lot of expensive materials, tools, tooling, and making the cost at the end very effective. And it is how this launcher has been.
C'est déjà commencé?
Yes, it is.
Yes.
So this lets you understand that we are now in 2020 or 2021 in the 2020s at the revival of some micro launchers, like it was at the very beginning of the space era in the 50s, because new technologies allows with miniaturization to obtain some interesting performance and very low cost with small launchers. Nevertheless, they are, I mean, it's just like having a bicycle. You cannot carry big satellites with in pieces. So it's a way to select some startups, to test some technology, and to have newcomers which are making their, let's say, their exercise and their proof with this type of launchers. And as soon as they reach some capabilities, they dream for bigger, and it is exactly the case for this Rocket Lab company. You see on the left the actual launcher, and the foreseen one, which is planned to fly in 2025, is much bigger. And somewhere we'll try to compete with launchers, a bit like Ariane. It's smaller than Ariane, but it's maybe a third of the performance of Ariane, or a quarter. But it enters in the capability to launch expensive satellites, which are paying much more the ticket than the small experiments, which are launched mainly for scientists, schools, universities, and so on, which are very interesting for all of us, because there are some demonstration. But of course, those people will very rarely make money with the small, teeny satellites of few kilograms, and so they are not ready to pay a lot. Yes, internal payload. Yes, internal payload in so yes, the volume and the weight that you can carry up to the orbit. Then, as I said to you, this heavy Ocean Angara launcher, we hope that it will fly. So that it has fly once and even twice, but not exactly the same configuration. But it was foreseen to be operational already 20 years ago. So we fully know that the Russians are fully capable. Technically, they have nothing to envy, yes, to the Americans or the others. But they are lacking of money. And then the newcomers on the front line are the Chinese, which are also able now to make heavy launchers, because they want to achieve not only the capability to put their own satellites in orbit, but also with manned flights. They have started, and they are now also a space and they made their mission, the first mission to Mars. They made a mission to the moon already. So we know it in the space family, in space community. It's not in all newspapers, but something is clear. China has decided to be a spacefaring country. Maybe they want to be the first one before 2050. For yeah.
Bonjour Philippe.
So they have they foresee to be. They really believe that they will be the first country in the world by 2049. So this is the very heavy launcher, the CZ-9, which is currently under development for going to the moon with heavy missions to the Mars. So heavy missions means able to carry people. So this competition is really fancy, and for the first time since the beginning, we don't see the Russians in competition with the Americans, or the European robbing some money to the Americans with some small launchers. But we see now on one side complete disruptive way to access to space, which is developed in the United States, and on the other side, the Chinese, which are running very fast, not with this new approach, but really with the will to be on the front line at least, and even maybe the first one. So not so far from Earth, because the space stations today are in low orbit. So they are only at 400 kilometers from the ground. So 400 kilometers is not so much if you think about that. And here you have a picture of the International Space Station, where a lot of people believe that all those panels are all cells, photovoltaic cells for energy, but in fact half of them are for regulation of temperature. So it's radiators, because when you are in space, you cannot exchange your heat. I mean, the energy you are generating heat for everything. Even when you convert the sunlight to electricity, there is a part of it which remains in heat elevation. And so the only way is to be radiant, to let this energy escape in the vacuum. And this is really a heavy concern. Having into account that the face, which is the skin, which is in front of the sun, is sorry, I will talk in centigrades. It's above 150 or 200 centigrades, just receiving the sunlight, while the other one, which is in the vacuum is at 4K, so minus 270. Yes, the temperature is very, very low. But as you have no exchange, in reality, you don't feel this very cold, because there is no water or no air that can exchange with you. So the temperature on the other side is minus 100 or 150 centigrade. So it means that between two skins which are on the opposite face of an object in the space station, you have more difference of temperature than between you and the inside of your oven. So that's something which is difficult to manage, and you have to do it every time. And every time you are not anymore in the sun, because you go around the Earth, and then you go from 14 times a day. You go from sun to night, yeah, to darkness. So this space station is an international one, and Europe has made a large part of it. In fact, more than a quarter of it, even 1/3, has been or designed or made in Europe. On some very, let's say, complex parts. So we can be proud that the project, of course, is mainly driven by NASA, by the Americans. And the Russians are there also, and they did deliver a lot of skills about life in space. But with respect to technology and deliveries of modules and deliveries of toolings, which are systems which are on board the space station, Europe has really made a great job. Also Japan. Well, this is just a nice picture of a French guy during. So I'm sorry, we put the EVA. EVA is extra vehicle activity. So you see, for the extra vehicle activity, as as I said, you need to protect yourself from the sun, from the vacuum, from the cold, and still to be able to move, work, and be autonomous. In the coming years, because some elements are already prepared on ground, there will be some private orbital station. So you remember that I said that the access to space, in particular with Elon Musk, but like it was somewhere with Arianespace at the very beginning, but now in the United States, access to space is coming private. So a large part of the money is coming from public demand, but the specification, I'll give you an example. The specification for an Ariane, it's thousands of pages, or for the space shuttle was maybe tens of thousands. Just specification, just saying this is what the public is paying. And when they decided to change the way to procure and to start what is known now as the new space, the NASA has just requested the requirement was on one page, saying I need to go there and you do as you like, but what I need, I will pay this amount of dollars for the kilograms and so on. They just request the services, not anymore the way it's performed. And this
going from detailed specs to functional specs.
Yes.
And there's a drastic complexity.
But it can arrive when you have an industrial capability which is sufficiently developed in the country in order that they can do it. Because when the industry is not sufficiently mature, you can ask for something, but very probably you will not have it or not at the price or at the time or maybe at the performance which is requested. So what happens is that in the beginning of the 2003, some laws are changed in the US, allowing that some public money can be spent with some risk, requesting some services, even for space. Like you can ask for services for mail things, something, but going to space. And this has generated this new space with a lot of hundreds at the beginning of contestants, and then 12, and then 6, and then now today we have 3 of them, and Elon Musk is the first one. Today the more efficient. So this is just to show that there is another private orbital station which is 14, this time by Blue Origin. So once again, private. Blue Origin is the second one. I talked about Musk and SpaceX, and Blue Origin is the company of Jeff Bezos, which is today the second one in the United States in the new space companies. And on their side, I said to you, the Chinese now are building up a large orbital station. And the Russians, which doesn't want to be alone because they will quit the internal space station. They have decided not to stay in the space station because they want to keep to recover their autonomy. So they foresee also to assemble by 2025 a new station. So what is interesting to understand is that the reason for the purely private station is that a lot of experimentation which was foreseen at the very beginning did not succeed, not because of technical concern, but mainly because of industrial property. Because when you want to find a new medicine or a new material or something that can be developed only in very, very low gravity in space, and then you have to say it all together to the guys which are doing it, which are Russian, Americans, at the end, you don't do it. So the idea today is to say all this time we have lost having the capability to make some scientific experiments, but not making business with it. So it was just fully international, which is still interesting, of course, but it was fully international science, but not business. So the way to make business with space is to say, I have a free flyer, so it's the nickname for those small stations, in which I will do what I want. If I want to generate some new materials or make a new experiment by my side, then I can do it, and the business model is not the same.
Because that means that they would actually patent and protect under the IP laws of the whole country the experiments that are run on the.
But you cannot patent because, in fact, the experiment is not there to try to patent, but everything is exchanged. So even if you patent, patent is not a real protection. The best protection is silence. The secret is the best protection. So the next step after is to go to a satellite that we have. So and it's interesting. It's a nice platform. It's called the Moon. On the Moon is a way, of course, to test going on other planets, because it's for us it's a satellite, but we can test a lot of things on it. But it's also a way to see Earth from far away. But there are a lot of applications today which are related to the ecology, the survey of Earth, sometimes even telecommunication. If you go with fiber, not fiber, with optical communication, laser communication, rather than classical electromagnetic communication, radio magnetic, because that's also wave. It's a matter of frequency. But in fact, it's still under analysis. But the use of the Moon as an experiment for Mars is rather clear. The use of the Moon as a satellite which can benefit to services provided on Earth, they are thinking of that. And there is one example which is easy to understand, that with very simple, not solar panels, but mirrors on the Moon, you can send sunlight to Earth, for example. And it's easy to do because you just have to put them on the ground of Moon. And I mean, it's not such if you can go to the Moon in order to do that, if the transportation is not anymore a problem, then at the end it's something which can be done for the benefit of all the human beings. So there are people thinking about that. Yeah. So this venture, I will say it this way, going to the Moon, is both an international story and a competition among a few foreign countries. The Americans are not alone. There are a lot of programs in which Europe is involved. Other operators are there in the large American programs. But China is there. And okay, so this is not a China's version, but this is the Starship that we discussed before. So the Elon Musk solution, which is docked with an Ariane spacecraft. Ariane spacecraft is coming from let's say, the old style way to go to the Moon. So just to let you understand that the pressure, the competition is such important that it was not expected at all. But a few weeks ago, NASA has decided that it was more promising in the competition against the Chinese to go to full disruption, and to choose this huge rocket, this huge spaceship, versatile, multi-role, oversized, and so on, rather than to keep the focused vehicles which were under development since decades by Lockheed Martin, Boeing, very well experimented on that, but with the vision of just doing what is in the spec. Elon Musk did not develop the Starship for the moon. It was not a purpose. He wanted to go to Mars, and for that he was using on Earth. He said, "Oh, but if you want, I can land on the moon. Where is the problem?" So you want to put yes, you want to put I don't remember. It was something like 14 tons on the moon. Is it a problem if I carry 80? But it will be less expensive. I'm sorry. So at the end, we really are entering in a new use of space with a new way to access. And this is a nice picture which show you aside the competitors for this lunar landing. So you have on the top on the right the one which was the national team led by Bezos, by Blue Origin with Lockheed Martin, Boeing, and then the Maxar competitor, which is in the center, and then you have people there, some people in in spacesuit, which is on the moon, which let you understand what is the size of the spaceship. And you see, Elon Musk said, "Okay, I propose you this." But it will be in the same time the way to carry the people, the way to carry the cargo, but also the first station, because we can rest. I mean, if I don't have enough fuel, then you can rest, and there is a lot of room there. But it can be also a big tank for putting something else. I mean, it's up to you. Once it's on the moon, then or you have fuel in it in order to quit, or you have no fuel and then you can use it on the moon. So it's fully open. So this is a good example of what's happening today. During decades, it was such complex to go to Earth, to leave Earth, and then to go to some planet. And we have developed very specific vehicles. And now that the technology has evolved, the vision has evolved, and we can say, okay, let us see bigger in order to accept to have some loss, but to have some reuse, some flexibility, and we don't need to develop this program. For example, Elon Musk has decided a few months ago that he will reply to the call. And he said, okay, I just can see how can I reuse my, so he changed a few things in the engines and so on, but it was not a project to be developed for that. The others were working 5 years ago. They started to work on the answer to this mission to land on the moon. So this is what is important is there. Of course, you see the vehicles and the size and so on, but what is important is that we are addressing space in a completely different. So this is a nice picture just to say that, okay, all this will have benefit if we have workers on the moon. So the astronauts are part of the Artemis program, and the Artemis program is one of the steps for the United States to go to Mars. And what I said before, that China is just there, not so far, and they have already on their side developed, and they are in production of some. Let's say on their side, it's still old style, but it looks like the LEM or it looks like the others. But nevertheless, if the Americans were not able to choose a new way, the competition should have been scarce, because they are focusing on the same date with a man able to work on the moon. 2028 for Americans, but since 5 years, they are losing 1 year every year. They have some difficulties in the program, and the Chinese were announcing 2030. But as now they have some new Russian friends, because Russia has decided to help China because they are not anymore in cooperation with the United States in the space station, and they did not find a way cooperate with Europe also on their side. They decided that they will help the Chinese. So the Chinese today have the probability to overpass the Americans if the Americans are not changing the way to go to the moon. Yes.
So
Yeah. Yes.
Yeah.
So we know, so cosmonauts are Russian astronauts. Let's say, occidental. Yes, spationautes. And not only they are developing so some things in order to go to the moon, but also lunar base and so on. So the ambitions of China are huge. So those pictures are old already, but it was a dream before. Now they are making everything in order to transform this dream in reality, and they try to be there before the Americans. And the idea for them was to have a permanently inhabited China lunar base by 2040. And it's another matter. So saying that you can send some people and they will survive for a while and so on, and saying that it's not exploration anymore. It's colonization. Yes, it's colonization. So this is where the competition is. And okay, just for fun, let's say to let you understand that everybody is thinking about how can we survive on the moon, because on the moon you are not protected by the magnetic field of Earth, which means that on the moon you don't survive. It's because the cosmic rays are very very dangerous, and after a few weeks you're dead if you don't protect yourself against the cosmic ray, like it is in an orbit which is elevated more than 2,000 kilometers around the Earth, because it's a magnetic field of the center of Earth, iron center of Earth, which is protecting us. So we will talk about Mars, but I just say that it's interesting to understand that going to Mars, the calculation has been made, and all the countries do agree with it. The way to survive against the cosmic ray is to be propelled by a nuclear rocket. I mean, it's better for you to have a nuclear generator 5 or 10 meters from you during less months, during only 3 months, rather than to fly during 6 months against the solar ray. So this is a real topic. A lot of people think that we can travel in space just like we can travel around in vicinity of Earth, but it's not the case. So Mars, the program. So the main program is foreseen to arrive with a crew vehicle in 2033. This is currently what is the plan for the Americans. Nevertheless, today we don't have really problems for the propulsion, as I said. Even if we want to have it nuclear, already some tests have been performed and so on. The problem is to authorize ourselves to send something like this above the heads of the people. Because if it falls down, I mean, if you have a failure and it falls down, then we need to be sure that it's okay. But it's not a technical problem. So today it's a political concern, because the fact that you cannot stay above your country if you send something in orbit. You cannot stay above your country. You cannot go purely vertical, because you need to have an horizontal speed in order to stay in orbit. So it's not possible not to cross over other countries. So for satellites and so on, which are a few tons and so on, which are not such dangerous, okay, it's accepted. The regulations are there, but for nuclear power station, not yet. So the next picture show you Martin Marietta and looking Martin specific concept. Because because the idea is to use, we call it a train, the space family, because we cannot assemble those vehicles on ground because they are made for living in without gravity in vacuum. They can be huge. We don't mind because they don't have to fight against the atmosphere. So there is no break with atmosphere and so on. So the shape of the vehicles are not at all the same that they should be if you want to travel on Earth. So the way today to have enough fuel, enough volume, enough power supply, and so on to be able to reach Mars is to have a huge vehicle. So it means they are assembled in orbit. Today there is no way. There is no way to make a vehicle which can take off from Earth and arrive on Mars. Nothing's arrived. I mean, maybe one stone. The biggest vehicle today, you can arrive on Mars like we are sending. You see the rocket today. We have sent some. Okay, we have sent some vehicles on Mars. Exploration vehicle on Mars. So which the weight is a few hundred of kilograms, or sometimes around 1 ton, which is more or less the maximum weight we have today put on Mars in a safe position. But there is no way to turn back. I mean, you need a launcher there. So you need once again a launcher which is hundreds of tons in order to come back. And there is no human being. So it's just kind of a fridge, big fridge, which arrived there, but you don't have the other activities, the other supplies which are needed for authorizing human activities. So just to let you understand that if we want to go to Mars and come back, the vehicles are huge, hundreds of meters. And so they can only be assembled in orbit. Nevertheless, this was my introduction to say that if you think of vehicles like Starship, which are big, with several Starships, it's possible to go to Mars. And it was the idea of Elon Musk, saying rather than assembling a lot of vehicles, I need to assemble 2 Starlinks in order to refuel one with the other one. So only with Starlinks, he has the Starlinks fully full of fuel, another one with the people, another one with the cargo, another one, and they fly, and with 6 Starships which are leaving Earth. So something like 30 Starships taking off from Earth, which allow to 6 to go to Mars. With the 6 arriving on Mars, you can have 2 in which there are some people, 4 in which there are no people, but which let you the possibility to refly 2 back on Earth. Yes. So the food, but the fuel. Yeah, in fact. So, but always with the same vehicles. Today, the ideas was also to say, I have a vehicle for each type of purpose, and you need a redundancy and so on. And then it was, as you see the train, so it was a huge vehicle, and then you have to disconnect one part and so on. But I said, okay, I oversize everything. I use always the same vehicle, which is inside. I fill it with different things, but still it's the same development, even if it is oversized, and I send lots of them in order to be sure to fly back. So this is what is the description. Okay, this is just a picture to recall that all this is in order to have the opportunity to live in an atmosphere which is 96% of carbon dioxide. Okay, without oxygen, and the temperature is between minus 100 centigrades up to plus 50. And okay, and the atmosphere is very thin, and the gravity is not the same. It's not well. Okay, it's not even. Not user-friendly, but it's another place. So this to say that the idea, of course, is to develop some local cities in order to sustain life on Mars. And this is for okay, not for today. But once we can say that we have some, you see the starships at the end of the picture, that once we have the capability to transport and to use in situ materials, then everything is seems authorized. Okay, so just a few pictures in order to dream, to let you understand that since 50 and 60 and 70s, a lot of real scientists had already some capability to project themselves, saying that if we can face the transportation problems we have discussed before, then we will have to invent a way to be able to live in space. And so they have thought about a lot of ways to regenerate gravity, to have the field protection, to keep the temperature in the correct, viable conditions, and so on. And some examples which are very interesting are those tubes, the O'Neill, which allow to have something which looks like Earth. You can generate conditions. So of course it's huge, but it's a way to generate conditions in which you have not real gravity, but synthetic gravity, and you can keep also an atmosphere because of this gravity. Just like it is today, it's kept. The gas can be kept by the velocity and not flowing a bit exactly like it is on Earth. Today, we have an atmosphere because of the gravitation, because of the weight of the gas, which make it stuck on the Earth. So also in space, if you make a rotation, you can in the same way with the centrifuge action. Yeah, you can capture a layer of gas. Yes. Yeah. Yes. So just to let you think, the people think that it's not possible, but in fact, it is exactly what we live today. We are living in an atmosphere, but the atmosphere could flow in the vacuum of space. If it stays on Earth, it's because of the gravity and the fact that the gas, the atmosphere has a weight. So those pictures are dream, but it can happen. It's not. It will be a long time. But,
it's not fantasy.
Exactly, fine. It's not.
It's future. It's not fantasy.
Yeah, it's future. Science fiction, but fiction, but because it's far away. But okay, just to let you understand that the people who are we did make that were very clever space engineers. So I mean, it's not against the law of physics. Okay, it's not against the law of physics. Maybe the mankind will never be able to do it, but it's not against the law. And see, so it was an example to say that the same type of life can be developed in such conditions. So I will be quick on that. Sorry, pictures are not very. They are very interesting, but I'm going quickly on that just to let you dream. Yes, I stop this. I stop on this one because it is SPS means solar power station. And today there is a competition which has started already a long time ago. Once again, mainly between the Americans and the Chinese, because very probably this is the power of the future. From Earth, from the one orbit on Earth, you can capture the sunlight and to orient it, yes, to focus, yeah, to focus, redirect and focus it on the ground. So there are some ideas with microwave energy and so on, but it's possible just with light, just with mirrors. You can concentrate it on an ocean next to a border, for example, and you can transform automatically because if you put with water, if you heat water above 850 degrees, and let's say above 1000 degrees centigrade you cut it in hydrogen and oxygen, and you have this new energy, which is hydrogen, which appears. So very, very probably, what will happen later on will be that some countries will compete in order to have the infinite capability of power from space. It's important to recall, maybe the people don't know, but in 1 hour on Earth, we receive from the sun enough energy, in less than 1 hour, enough energy for the whole mankind. It means that the sum of energy used by mankind during 1 year, which means crops, agriculture, of course, industry, eating, houses, everything of the whole mankind is just less than 1 hour of sun. just okay. This is interesting because I think that, of course, we will not see it, but it's very probably our grandson will benefit of this technology because it's such an interest that the competition will be there. And there is also another interest because when you have this kind of lens from Earth, you can decide to burn the people you want. So there will be, the competition is already running, even if very few people know it.
Don't be shy, and please ask your question for Marc. Keep going.
Please.
Yes.
May I?
Sure.
Thank you very much. Very interesting. Something you didn't speak about is tourism. We have heard about some experiences, some startup and more experience at the end that start to send ticket. I don't know if there will be smart tickets to space. Sends ticket to space. What about it?
So first of all, there is a huge difference between going to space, which means reaching an altitude over, it depends of the country, over, let's say about 100 kilometers or 60 miles. And with this, you say, okay, I am a spationaut. I mean, I've been in space and for a few seconds or a few minutes at the overall, and then you are back on Earth. So these kind of tickets are, let's say, affordable, more or less. So they are proposed by Virgin Galactic today in the coming weeks. First of all, they will fly by themselves, but Blue Origin will propose it also. But the ticket is a few hundreds of thousands of dollars.
Yeah,
so still, this is the cheap one. And then it's another story. If you want to be in orbit around Earth or in orbit around Mars, just to let you understand, reaching space is not a matter of altitude; it's a matter of speed. So reaching 200 of kilometers and then falling back on Earth needs only 5% of the energy you need to stay at 200 kilometers. Because if you want to stay in orbit at 200 kilometers, then you need to accelerate up to 8 kilometers per second. Otherwise, you fall back. So it means that, okay, those guys, they are paying, so they are astronauts, they have been burning only 5% of the energy, which is the one you need to stay in space. So the second type of ticket is to go to those free flyers. I was talking about those private stations which are around Earth. I was talking about experiment, making business, but one part of the business also, if there are some customers, it seems that there are, can be to have 1 week in space in a nice hotel, which is in fact a space station. The ticket will be higher, so it will be very exclusive. But yes, you're right. So maybe I was not clear enough. For being just to go to space, there is a closed business. I mean, you can make the vehicle and so on to do that, and then you will sell those tickets just like going to a show or something like this. And the other activity, which is going to space and to pay for going to space, means that the mean is able to put something in orbit or to go to Mars and so on. And then it's a side business. You see, it's not, the business cannot be today. It's not possible to, there is no business plan today to develop in orbit tourism. No way. But there is some room that if you have some space stations for some other purposes or paid by public money or for other commercial activities, then you can imagine to also have some customers for leisures.
There's another
But just a word, please. To go to space, there will be a hard training. There is a hard training to whom go to the space lab or the space station, etc. For the one who do some up and down, there is a special training, or it's like going in a super jet.
It's not exactly like going in a super jet, so it's less than that. But still, it's not a real training, but it is a check, medical check. Okay. So in particular, your weight, because the way your body acts in front of the acceleration is highly depending on your weight. In fact, inside your body, the way the organs are there and so on. So there are some limitations, but today, no, there is no real training.
Thank you.
Just for this trip.
Thank you very much. And compliments.
Yeah, good evening. This is Vincenzo Pennetta from Cologne, Bonn. Even though I'm Italian, but I'm not a German, but I live here in Cologne since, let's say, since 12 years now. I work for the European Aviation Safety Agency, not the ESA. Many people tend to mix the two. But even though I have many friends that work in ESA, actually all the Italian astronauts are friends of mine because we have been in the Italian Air Force Academy together a long time ago anyway. So yeah, my question is very, thank you very much. It was a very interesting presentation, was very clear. And actually, you pointed out that now there is a change the use of space. So everyone wants to go into space, civil for civil or military application and so forth. But my question is, who is going to regulate who can go and how can go into the space? I mean, is there any kind of intergovernmental agencies that who's going to regulate who's going to be there? Because there's there's going to be, let's say, a bit of traffic over there in the next 50 years over there.
That is a very good question. Of course, the matter is not under control, but it is a lot of people are thinking about that. So first of all, there are some international communities, but there is no law today because it's not depending from a country, and so nobody, even if somebody wants to say there is a law, there is nobody to be sure that it will be applied. So today, clearly not really the Far West, but it's a matter of cooperation. It's a matter of being aligned for some of the activities. Up to now, the only thing which exists is the treaty which was signed in 1957, which says that nobody can decide that a part of space is owned, so it's for everyone, and so on and so on, and peaceful. I mean, not completely peaceful, but not with no massive destruction weapons. I mean, there are few rules which has been signed by almost all the foreign countries at this time, but it does not prevent from every risk, and in particular, it does not prevent from the collision risk or the use of the space orbit and so on. The only international regulation that exists for that is linked to the radio telecommunication, because a lot of satellites are used for television, radio communication, and so on. And because of the radio communication, there is an international body, which is the ITU, which will allocate or not the authorization to be on a place and to have some emission in certain bandwidths. So there are let's say, it's not fully the desert in terms of law, but there are small pieces which has been developed when it was needed to cooperate in space. So we can think that very probably it will continue in the same way. And I can say to you, for example, it's very interesting that there is no definition of where start space.
Oh,
Altitude,
oh,
and it is on purpose, because the country said no, it's not possible. If we do that, I mean, it's better that there is no rule. So instead of what, we'll have some difficulty, we will have to fight and so on.
yeah.
And today, so some ambiguities are maintained because it's not interesting to regulate things which will not be controlled.
Okay, so that the challenges are not only technical, but seems to be also legal challenges ahead of us.
Yes,
these things.
yes. Predominance, I mean, dominance. The United States clearly said that they are acting for space dominance.
Yeah.
Which means that they must be sufficiently present in space in order not to be constrained by the other about what they are doing with it, but still remaining in the signed. Today we are not in war, so they signed the treaty and.
Okay.
So
yeah,
yes,
that's why. Yeah, the United States they founded the Space Force now, no? And then.
Yes.
Yeah.
But,
Do you think that the Chinese or the Russian is going to do the same? Also, I don't know if the European Union is going to make something similar.
In fact, the Russians have created the Space Force, the first one. They started with the Space Force, but at the very beginning of space. So
yeah, okay.
in 1950, the Russians had already a Space Force.
Okay.
May I ask a question, please?
Okay, thank you.
Yes, my question is, do you think that there are other beings out there beside us, little earthlings? Because what we may consider as our mutual challenges among countries, there may be other entities out there who are much more advanced than we are and could really flick us very easily.
So very good question and very difficult to answer. So we can think, but we cannot know. What we can say, we can take the example of what's happening today on Earth, in order to understand if we can meet once or not. Some place where that can be live, we have identified already a few hundreds or even thousands, very far from here, at several what we call the light years. Which means that at the speed of light, you need 1 year to go there. Okay, and they are at thousands of light years. So it's just like you have a flea in your garden, and you ask yourself if during the life of this flea, which is maybe 1 week, she will meet a flea in Australia. Probably never. And it does not mean that they are not alive, and they can be, but today, you know, the human beings are only maybe 100,000 years old, if we can say, in terms of as we are. And the time to go to meet equivalent species, which can live somewhere else, is about the same time. So it's very difficult today to imagine that even going at the speed of light, which is very far from what we are able to do now. So probably there are, probably we'll never know, and it's very much more than probable that we will never meet.
Too far.
No, it's too far.
Yeah, too far.
They be around already, because the whole issue of UFOs that seems to be much more of an object of discussion right now. Isn't there a report that is being developed or that just came out, maybe looking at the UFOs that some military pilots have claimed to have seen, certain manifestations that they cannot explain? So what are your thoughts on that?
I think that from the very beginning, a lot of things have not been understood by human beings. And very often, some gods even were considered just because the human beings were not able to understand the thunder or something else and so on. So more and more, we understand the things which are around us, and things which were looking like sorcellery, which is the things, or or mysteries once we have started to understand, oh yes, of course, now I know. So I think that we will discover what it is about. I don't say that they have not seen anything or so on. I just say that, okay, we have still a lot to learn.
Fair enough. Thank you.
The last one. Please.
Yes, sure.
Thank you. A very pragmatic question this time. There is a lot of material in the sky above us. What about the problem of the waste? Spare parts and all the things. Is this a real danger? And what's the time needed to eliminate this naturally when they fall down and burn?
In fact, there are several answers to your question, because it need to be split in the law of physics oblige me to split in several parts. First of all, up to an altitude which is about a few hundreds of kilometers, less than 1,000 kilometers, there are still few molecules of atmosphere, which means that there is a very, very low breaking, meaning that it will fall down once on Earth. But once can be hundreds of years, thousands of years, and okay. So today, if you are below 350, if you are below 400 kilometers, you should fall down in less than 25 years. But it's not gradual. I mean, once you are when there is no more nothing else, then you will never fall down. So today, the satellites, for example, the geostationary satellites, they will never fall on Earth. I mean, very probably the Earth will be eaten by the sun when the sun will grow much before those satellites will. I mean, they will never fall on Earth.
Do they represent a danger for the rockets and other space station?
Yes, because the speed of those vehicles, because they are in orbit, are of several, about, let's say, 10 kilometers per second, but less than 11 kilometers per second. You quit the Earth. 8, it's the very start of being satellites. So more or less, they are flying at 10 kilometers per second. So, and they are not flying all in the same direction. So yes, if you hit another one, then it's clear you're dead. I mean, it's a full destruction. The energy is such that it's much faster than the bullet of a rifle. Huh? So the space station today is flying much faster than the bullet of a rifle.
Okay. Good luck. Thank you. So
about cleaning it. So the question was, okay, is it dangerous, and then can we clean it? Today we cannot, because today there are because when you are not on the same orbit, you are not on the same orbit. You cannot. It's very difficult to reach it. I mean, you need to have exactly it's like location. In space, you don't have location. You have speeds. What is to know where you are on Earth, you have a localization with a point. To know where you are in space, you cannot be immobile. You have a speed, which is at what is the velocity of the speed, and then what are the directions of the speed. And this is the speed, and you keep it forever. So you are not stuck on ground. You are stuck on the speed. But as far as you are not exactly at the same speed at the same moment, you will not meet. You can cross and you can, but you will not be able to catch it. So today it's almost impossible to catch all the things which are flying in orbit, in low orbit. It's almost impossible. What can happen is that with the SPS, the solar power station I was talking about, with those you can decide that you can burn them, or you can partially transform the metallic in gas in order then to generate some brake or to generate some acceleration, and then you can push them down on Earth. So the cleaner this famous solar power station is really the tool when we will have it that will change the life of the human beings.
Fantastic. Thank you.
Any other question?
Just one. Hi, Philip.
I hate to ask so many questions, but this is so fascinating. Can I ask, indulge me one more? So I follow what you're saying, but how about meteorites, for example, that come and hit the Earth? Is it that they were on some orbit which has changed? Are they on the same orbit as us? How do they hit us?
There is an infinity of answers because they can come from everywhere. So there are meteorites which are part of the satellites of the Earth since ever. I mean, you know, Earth has been made by meteorites which collided and at the end aggregated. So some have not yet joined Earth. I mean, this has started several billion of years ago, and then for creation of the Moon and Earth. So still there are some of those species that should one day arrive on Earth, which will arrive. So this is one type of category. Then there are some others which are not around Earth but around the Sun. So because we have the Sun, so it's about the same story, but they are flying, and maybe one day we'll fly them. And the comets are like those ones because they have a very eccentric trajectory. It means that they are coming very next to the Sun and then very, very far at the speed. So sometimes we see them because they are not far from us. And maybe one can collide today on Earth. And maybe there is one which is already known in a few, we don't know, a few thousand of years, a few hundred of years. We have never seen it because the trajectory was never there. It's so teeny that we cannot see it because it's very, very far away in space. But maybe it's written somewhere that it will arrive on Earth and collide. We don't know. And then we have the last version of those objects, which are not from the solar system, but which come from outside of the solar system. And they are also crossing, and it can happen. So today, we don't know. Today, frankly talking, it can happen that something hits Earth. Big, because teeny things, every second, enter in Earth's atmosphere. I don't remember how many thousands of tons are falling on Earth every year, but it's huge. And it's huge. It's enormous, the quantity. And you know all the what you are calling the what you want shooting stars. Yeah, the shooting stars. They are meteorites. And what you see, they are burning when they enter in the atmosphere because they arrive at several kilometers per second. So when they enter in Earth, the friction is such elevated that they completely melt and then burn, and they are transformed in gas. Such the temperature is elevated, and so the shooting stars are meteorites. And there are in August, for example, a period where the Earth is crossing a place where there are small stones which are in gravitation around the Sun. So this is exactly why on the 15th of every year, on the 15th of August, you see more shooting stars than the other days, because we are going, the Earth is arriving in this dusty part where there are some meteorites.
Philip, can I ask you a question? Philip, if you remember, I worked in the European Space Agency as the CFO. They tried to hang me every day when no money was available, but overall, my knowledge was less in the technical area than in funding area. But this is extremely interesting, great, and thank you. Only for the Moon, if you allow me just for a minute, coming back to the Moon, you remember that the Director General who just went, Mr. Werner, he brought up this little idea of a village on the Moon, the famous village on the Moon. He was ridiculized by certain people, but it is exactly a little bit in line with some visions that you just mentioned. Now, for the moon as such, we all fought on the most exact description of the project going to the moon. And one was, we need the moon definitely for observing the Earth better up there, steadily, and without risk of what is going to happen to the space station in a couple of years, possibly 5 to 6 years. Secondly, we need the natural resources, if there are any, even when it's difficult to start mining them. Thirdly, for security or even military purposes, as you said, the Russians are looking, the Americans are already looking for something which they call space military or whatever. And especially also for fulfilling the dream of mankind going further out and using the moon eventually as a refueling station. And the latter seems to me extremely important when you just showed us these huge rockets necessary to come back from the Mars. A lot of people perhaps have in future the chance to go to the Mars. They will never come back. As Mr. Musk explained in one of the meetings of the International Aviation Conference. But here, what do you think? What is the most important goal? Natural resources, security, the risk of military collision eventually, or purposes, and lastly, refueling of rockets that eventually go to the Mars. I hope it wasn't too long, excuse me.
No, it's okay. And I of course, I fully share what you say, and I know very well those topics, and I had the opportunity to discuss with Turner on this some years ago. I think, as I said, the first I gave in the list when I was talking about the moon was to be able to survey the Earth. I think this is the most important, and for me there is no doubt about that. After that, the other purposes are opportunities. The fact that in situ mining allow to have some materials with for less energy than if they come from Earth, because when you are on Mars, when you are on the moon, if you are next to the geostationary orbit, in fact. So as I said, what is important in space is not the position, it's the speed. And the delta V, what you call, so the variation of speed you need to go from one position to another one, makes that it's much cheaper if you are in a geostationary orbit to go and pick up something on the moon, because you need some materials, some fuel, some stones, something, than on Earth. It's less costly. So yes, there is this economy about having a big reservoir of materials for space applications. There is no doubt of that, but it is more an opportunity than a goal by itself. Just like what you were saying about having some fuel stations, things like this. This can be done also in orbit around the Earth. So depending what type of vehicle, we can decide to put the fuel stations directly on orbit or to put them on the moon. But at the end, there is not so much difference. I mean, it's once again, it's an opportunity. And the last, which is not the easy one, is about this military application. Yes, of course, there is a risk that maybe moon can be a theater for a war, and because there are some interest to be there. It's also a position where you can decide to, as I said it, you can decide to have a high generation power station which can, I don't know, focus something against satellites of others and so on. I mean, it's a location. It's a location which can, which is a strategic location, in particular on the position which is toward Earth, because the Chinese have been on the other one, the one which is not in front of, not visible, not on the other side, which is a nice position for having a look on the outer space, but it is much more science than direct application. So let's say half of the moon is really interesting for the human beings, and much more for having a survey on Earth, which can be a space survey or maybe military survey, but in any case, survey of Earth.
Thank you very much, Philip. And this is really, really interesting to have this go on a new vision on that. And I also thank my former club, Alliance, Paris Alliance, je vois là, oui, and it's a pleasure. And the new Director General, by the way, Aschbacher, he was also in Paris Alliance for some time with me. And so it's a pleasure having you, Philip, and hearing this and seeing all you again. Thank you.
You're welcome. Thank you very much for your comment, Michael. I just wanted to add, to go back on the question about the meteorites. As far as I know, but I'm speaking under Marc's control, the last major meteorite that is documented as hitting Earth and creating significant damage was the one that hit Siberia in 1908. It's been documented. It created a huge crater, and it devastated several thousand of square kilometers of tundra. Thanks be to God, it was in the Siberian tundra. Mm-hmm. So it probably killed a few thousands of wolves and bears, but it's about that. But it created a devastating area in the center of Siberia. But that was 1908. So statistically speaking, if the law of large numbers plays for us, we still probably have a few dozen years before another one hits. But then once again, the key message from Marc is that it is based on statistical law, because we just don't know.
Thank you. Thank you.
When you have big numbers, the statistics have a signification, but in that case, there are only very few which can hit Earth. So statistics, if we come back, we don't know exactly how many million years, but about something like 60 million years. Maybe there was this big meteorite which has fallen, and, yes, in dinosaurs, and creating then some.
Well, the scientists for 65 million years ago, it was bigger than the one in Siberia.
Yeah, so but it does not mean that every 65 million years once will arrive. So very difficult. I think that there is nobody has the answer. We can have.
And we remember what John Maynard Keynes used to say: in the long run, in the long term, we were dead.
No, we don't know.
Is there a last question? We have time for one last question from Marc. Is there someone in the audience that would like to ask a last question? Well, if not, then I will pronounce the end of this conference. I want you to know that we recorded the conference, so it's being recorded. And so I will keep that stored on my hard disk, and that means that for those of you either in France or in Roma or in Köln who would like to share it with other members, I would be glad upon request if you send me your email address to send it to you via WeTransfer, because this is something that will weigh about 600 meg, and I will then be able to forward it to you upon request via the tool WeTransfer, which is valid for 7 days. But that means we will be in a position to share it with you if you want to dispatch it more widely in your respective clubs.
Merci, thank you.
We will first thank Marc for his investment, because it took weeks of preparation. I will also thank Michel Lenné, who is also Marc's colleague at Dassault Aviation, and who was the key man in organizing things. This is his idea, and he was the key man behind creating the program, meeting us, having us meet Marc, and putting together that conference. So let's thank all of you in Germany, in Italy, for your time, your attention, your being there. You're getting in, and also our friends in Washington. I hope they are still online. As I say, the next step for us is to have a presential face-to-face meeting around dinner, either in Paris or in Rome or in Köln.
We hope.
We hope about
yes,
that.
For sure.
We hope about that.
We hope
I thank you very much.